There are some levels of exhaustion that are just unfathomable. I'm Eric Darling with Darling Data, and in this video, I'm going to talk about how parameters to some extent, just a tiny little bit about local variables and how they behave with views that contain windowing functions. This is sort of a wrap-up video because I've talked about some of these things separately, but with the advent of SQL Server 2020-22 and a brand new compatibility level of 160 available, there is a little bit more to talk about. And boy, is my heart tired. So let's dig right in, have some fun. Now, words of wisdom about windowing functions. They are generally aided and assisted from a performance perspective. And all those P's are really going to test if my audio is synced up with any degree of accuracy. If we create them, well, let's look at our windowing function, and let's look at our query generally. We are generating a dense rank. The same thing would go for any other windowing function. We are partitioning by owner user ID and ordering by score descending. Aside from those two columns that are also in the select list, we also have creation date and last activity date. And so our index for this windowing function and the query more generally is going to be keyed on owner user ID and score descending and include creation date and last activity date. I like to include, when reasonably possible, all of the columns in the select list to cover the query so that we don't have to deal with SQL Server thinking about key lookups, because SQL Server often seems to make counterproductive choices when it comes to doing key lookups. Either not doing them when it would be a great idea, or doing them when it is a pretty terrible idea. So we're just going to make sure that we don't have too many choices to worry about here. I'm going to worry our pretty little heads about this one. So I'm going to create this view called Pushy Paul, error-free, professional presenter over here. And we've got query plans turned on because, believe it or not, I've had this script file open for a while, making sure that I have a reasonable number of bases covered when I give you all of this information that you're going to forget about mere moments from now. But let's run this query. Let's select from our view, and we're going to use a literal value here. Now, various things could trip this up. Simple parameterization would be one of them, and the database level setting. Well, let's backtrack a tiny little bit. The query optimizer. Part of the query optimizer choices. One is to add simple parameterization to a query. That could potentially trip this up. Another is the database level setting, force parameterization, that could also trip this up. But when we use a literal value and we run this query, everything returns nice and fast. Right now, we are in compat level 160, and even though this looks like we got a simple parameterized query, we didn't. It was attempted, but it was not actually used. If we look at the index seek over here, we have a literal value. I don't know what a value is. It's not a town in Colorado. But we have a literal value down here. We do not see a parameter down here. So simple parameterization was not successfully applied to this query, though it was attempted. Surprise, surprise. There are weird things in query plans that no one should ever have to explain to anyone. But we do get a quick index seek. We do get an accurate cardinality estimate, and why wouldn't we? And everything seems right with the world here. Now, if I were to wrap that view inside of a stored procedure and replace the literal value that we would call to invoke our view with a parameter, user ID, declared here and used here, we would see some substantial differences in the query plan under compatibility level 150. So let's run these, and well, these run. I will say that if you were to use the global trace flag 4199, if you were to use trace flag 4199 as a query in here, or you were to use the database scoped configuration query optimizer hotfixes, you would not run into this in compat level 150. You would also not run into this in compat level 140. I'll tell you exactly which cumulative updates that applies to towards the end of the video. But if we look what happens here, the top query no longer features an index seek. The top query now features an index scan, then a window aggregate, and then a filter. Whereas the bottom query just features the index seek and then the window aggregate. The filter is, of course, going to be the parameter for user ID, because that is the only filtering element in the query. The main message here is that when you have a windowing function in your view and you use parameters under certain conditions that I will tediously explain over and over again, I'm going to feed that dead horse a full meal. The local variables and parameters can't be pushed past either the window aggregate, which is just a batch mode sequence project, or the row mode sequence project plan operator. Fun, right? It's exciting. It's great stuff. Under compatibility level 160, that story changes a bit because there was a more recent optimizer hotfix that allows for that to happen. So if we switch this to compat level 160, we will see both queries use, well, slightly different execution plan, but here is our sequence project and, in parentheses, compute scalar. Thank goodness it's not just a compute scalar, so that we could tell that we are projecting a sequence here, because everyone who looks at a sequence project operator immediately understands that they are projecting a sequence of some sort, not just computing a scalar. But both of these queries now get index seeks, even though one of them, this top one, has a parameter, and this one here is still lying to us about getting a simple parameterized plan. Well, there's not much you can do there, is there? Could throw a 1 equals select 1 on there to clear things up, but then y'all would accuse me of cheating or something. So let's switch back to compat level 160 and talk a little bit about why this happens. Views, of course, can't accept a parameter. When you create a view, there's no parameter list for passing into the view. You just create the view, and then you call that view from somewhere where you decide what you want to filter things on. The optimizer, except under conditions that we will discuss quite a bit in this video, cannot push parameters past sequence project, compute scalar, or window aggregate operators, which in my earpiece I'm being told that window aggregate operators are really just batch mode sequence. Oh, I forgot a word in there. PROG project. There we go. It only works with constant values, like literals, right? Unless you are in compat level 160 or compat level 140 or 150 with certain patch levels and database level settings, query optimizer hotfixes, trace flag 4199 enabled globally, or trace flag 4199 enabled at the query level. Recompiling would also allow for this because it would reduce your parameter or local variable to a literal value. Another way of getting around this limitation is to create a inline table valued function in place of a view, because inline table valued functions can accept parameters. Inline table valued functions also prevent simple parameterization. And even under compat level 150, this works out pretty well. All right, there's our inline table valued function, and even if we stick that inline table valued function inside of a store procedure, even in compat level 150, we will get the execution plan that we're after, where the parameter value is pushed past the sequence project compute scalar, and we get an index seek rather than a full index scan that takes 6-7 seconds like we saw in other demos run during the video. Our seek predicate here is not on a literal value, it is on the parameter value passed into the inline table valued function. So, SQL Server 2017 cumulative update 30. SQL Server 2017, of course, maxes out with compatibility level 140. SQL Server 2019 CU17, which of course maxes out at compat level 150. Both have this query optimizer hotfix available, which again, trace flag 4199, the database scope configuration query optimizer hotfixes, and of course SQL Server 2022 RTM and beyond, without making any of those changes, either the trace flag in either method or the database scope configuration, will fix the issue with parameters, local variables, and views without a recompile hint. Fantastic. You don't need to go rewrite all your views as inline table valued functions, though. I don't know. Maybe I don't think that's such a terrible idea. Maybe I think that's actually an okay idea. One, it fixes a lot of weird problems like this, and two, it gets you in the habit of writing inline table valued functions instead of crappy functions like scalar UDFs or multi-statement UDFs. But you could fix this with trace flag 4199 as well. Do this, and trace flag 4199 would address the issue. Good for us. So one thing that I do want to talk about a little bit is local variables, because even though the query optimizer hotfixes will address the issue with not being able to push the predicate past the sequence project compute scalar, or the batch mode window aggregate, which is just the batch mode version of a sequence project, they do not help improve, none of that helps improve cardinality estimates at all. So even we're in compat level 160, and we run this, even though, no, did I switch that to 160? Oh no, I'm I see now. I'm forcing compat level 150 in here. Silly me. Like I said, it's all so tiresome. So if we look at this query plan, we are forced to, again, scan the whole index and apply the filter later for that local variable. Now, if we still use compat level 150, but we enable trace flag 4199, we'll get the seek plan that we're after. But even doing that, we get the really crappy local variable density vector guess there of 12 rows out of 27,901. I apologize for causing you pain, but I just want to make sure that y'all caught that on this one as well. It's only another 6 seconds of your life. What were you doing anyway? Can't even say I love you in 6 seconds. But we continue to get the crappy estimate here. Right? The estimates are over here because we have to grab every row. The estimate's only bad at the filter where there's actual cardinality estimation to be applied to a filtering element in the query. And that also goes for if we hint to use compatibility level 160. We run this, and even though we get the seek plan that we're after, we still get the terrible guess. So even though some effort was made by the nice folks who brought you feedback to fix this issue, we still do not get anything resembling accurate cardinality estimates from the local variable. So I would advise you, except under closely monitored circumstances, to avoid local variables where possible. Pain, swelling, itching, redness, nausea, vomiting, diarrhea, and possibly even death have occurred when using local variables. So anyway, the larger point here is that Microsoft does do some valuable things across versions of SQL Server, of course, and even in sometimes in cumulative updates. Of course, we don't really have much choice anymore since we will never see another service pack again. We will only ever see cumulative updates from now until forever for SQL Server. Maybe there will be a different word for it at some point later. But anyway, the main point here is that there are some things that can be fixed by upgrading. There are some things that can be fixed with trace flags, and this is one of them. This is a pretty good example of it. I've seen performance issues related to this crop up, I don't know, probably a dozen or so times in my time consulting. So this is a good thing to keep an eye out for in query plans. Of course, I do generally recommend keeping an eye out for filter operators in query plans because they often indicate that you have done something monstrous. Not always, of course, but they are a good thing to keep track of because they usually mean that there was some predicate that possibly could have been pushed down closer to when you touched a table or index, and it wasn't. And you could have been dealing with a lot fewer rows traveling throughout the course of your query plan if you were able to apply those predicates earlier on in the query plan. I think probably the best example of that is when someone does a left join to a table to find rows that don't exist, and they filter on where the left join to table is null. Those tables have to be fully joined before that filter can be applied to rule out null values. Even when you're using a not nullable primary key, you have to deal with that. Of course, that situation is usually better dealt with by using not exists, which can eliminate those rows at the anti-semi-join rather than fully joining the tables and looking for nulls after the fact. Some things like windowing functions, like if you want to run a query and look for where row number equals 1, I mean that's an expression that you just have to gin up at runtime. That's not something that you can not something that you can really help, but something like that would also result in a later filter operation because that value wasn't stored anywhere where you could persist it, index it, and filter on it earlier in a query plan than after you have generated the row number. So anyway, I think that's about it for this one. I think that's also about it for me today. I'm gonna, I don't know, I guess, eat a dinner and try to forget the computers exist for a little while. So thank you for watching. I hope you enjoyed yourselves. I hope you learned something. I hope that this wasn't too tedious for you. And remember to do the old like and subscribe, 1-2 shuffle for me. Anyway, thank you again for watching.